Hi there, guys. Today we're looking at analyzing surveys and samples. And this particular lesson is just a little bit different than everything we've done so far this year. There's not really going to be any math involved here. This is more about kind of reading the situation and determining if it's mathematically sound based on the way things are being done. Okay. And this is an important part of statistics to make sure that we are approaching things from a way that is kind of fair and will give us the best results when we start looking at the math. All right. And so this becomes an important part of this thing because you want to make sure that your data is reliable. And if you don't approach surveying and that kind of thing in the best method possible, then what's going to happen is your survey results are going to be invalid, and the math that we do after that is going to be pointless. Okay. And so, as we're looking at this thing, the first thing we see here is a survey. A survey is just a study of one or more characteristics of a certain group, okay? So, maybe we want to know how many people play a sport or something like that. We would take a survey to see how many people play sports and how many don't. And then from there, we could look at the survey results in terms of what sports people are playing and start to dive down into percentages and that kind of thing, all right? The population is the entire group that we're trying to collect that information from. So again, going back to that example that I used for the survey, if we're looking for people who play a sport, well, maybe we're looking at specifically high school students who play sports, or maybe we're looking at senior citizens who play sports. Kind of see what those different age groups are into. So the population is the group that we're targeting. All right. And then the sample is the actual part of the population that we survey. The fact of the matter is that if we're trying to figure out, what sports high school students play, it would be almost impossible to survey every single high school student to get those results. We wouldn't be able to use everyone from that population. We're going to have to use a sample. We're going to have to use a sample of the population to get those results, and then kind of look at that in terms of, okay, if the entire population follows that sample, this is what we would expect, okay? And so again, even if we were just looking at York Suburban High School, it would be really tough to survey everyone. We might survey a portion of the population, and that would be our sample, all right? It's the people that we're actually surveying to get an idea of what the population would do, all right? And so the first thing we're going to look at here then in terms of that is sampling methods, all right? We have a couple different sampling methods. See, we have to choose our samples very carefully. So a random sample is when basically everybody in that entire population has an equal chance of being selected. Again, if I go back to the example of York Suburban High School students, I want to know who plays what sports, all right? I can't survey everyone, so maybe I do a random sample, and I just take everyone's name from the entire high school, and I draw 100 names out of a hat or something like that. That would be a random sample, and I would just survey those 100 students, and then I would use that information to generalize the entire population, okay? A stratified random sample is when we basically break the population up into distinct groups and then randomly select from each group. So a nice way to do this, again, if we're talking about York Suburban High School, is I might get a couple different teachers involved. And I might say, okay, I want each of you to pick 3 students from each of your class periods. All right. So just randomly select 3 students from each class period. So what we're doing is we're breaking the students up into little distinct population groups into class periods. All right. So each of those classes, 3 students have an equal chance of being selected. All right. So instead of randomly selecting from the entire population, I'm randomly selecting from little groups within the population. Okay. And the nice thing about doing that is sometimes then you can break the population into different categories. So maybe we would randomly select from the category of boys separately from girls or something like that, so that we can start to make distinctions between those groups as well. All right. And then a systematic sample is when we use like a rule to select the members. So maybe we stand in the front lobby and we take every 10th student who walks through the door and survey them. All right, that would be a rule because we're using a systematic approach. We're not randomly selecting, we're selecting every 10th student. All right, so it's not random. Or maybe as we entered the auditorium, something like that, randomly selecting every, fifth student or something like that. All right, or every student who's wearing red that day, okay? When we're using some kind of rule to determine which students are being selected, so it's not random, all right? So again, the three situations, random and stratified random are the ones that students typically get mixed up, all right? A random sample is when we select randomly from the entire population, but stratified random is when we select randomly from groups within the population. So we split the population into groups and then randomly select from there, all right? And then systematic, we're following a specific rule to select those students, okay? So a convenience sample is basically only members of a population who are accessible are selected. This is basically where we take kind of the easy route. And this is not always the best way to go, all right? But if I was trying to get a bead on like the population at York Suburban, would be if I only surveyed my classes, okay? And, that would be convenience because instead of branching out and trying to get other populations within York Suburban, I would only sample my classes because that's easiest for me. Or maybe something like, a coach wants to ask student athletes about something, but they only survey people from their team. Okay, that would be a convenience sample because they're only going to those folks that are easily accessible to them. All right, and then a self-selected sample. This is when members of the population select themselves by volunteering. So anytime they're volunteering, so if somebody emails every student at York Suburban with a link to a survey and says, "Hey, please fill this out. It's optional." All right, that's self-selected because only those who choose to fill out the survey will be part of the sample. All right, so convenience sample is when we just take a route that's easiest because we're coming into contact with those folks anyway. The self-selected sample is when it's based on volunteering to take the sample. All right. For example, a company is surveying employees on safety regulations. They randomly select 50 employees from each factory to complete a survey. So the first question is, who's the population? In other words, who are we trying to get information out of as we look at this thing? All right. And so for this, we want information about the entire population. In terms of the population, we want the entire company. Okay. So every member of the company. All right, that's our population. That's who we're trying to reach with this thing, okay? And then the second question is, what's the sampling method? And so for this one, again, it says random in there, but we're randomly selecting 50 employees from each factory. In other words, the population is already broken into groups. It's broken into groups by factory, and then we're selecting randomly from each of those groups. So that would be stratified random. And again, it's stratified random because we are breaking the population into groups based on the factories they work in, and then selecting randomly from each of those groups. Okay, and so there's a very slight distinction between random and stratified random. Okay. And then the last piece, it said if the method above was changed to surveying every 10th employee alphabetically, then what would the new sampling method be? That would be systematic. Okay, because now we're using a rule for selection. Okay. The next thing we're going to talk about is a bias, okay? When a survey makes assumptions that may or may not be true, all right? And this is one we have to be really careful of when we're looking at, creating surveys or even creating survey questions. This is a big one. We want to make sure that the questions aren't biased, because if the question leads people to answer a certain way, then our data becomes invalid. And that's what all this stuff is about. It's about making sure that the data we collect is going to be valid, all right? Because if the data is not valid, it doesn't matter what we do with the numbers after that. For example, if I look at something like this guy, a reporter asks, do you prefer exciting action movies or boring documentaries? is the question biased? And hopefully, as you're reading that, you're going, well, of course the question is biased, because when you read that question, it sounds like they're trying to convince you to pick the action movies, okay, because of the way they're described. So yes, there's bias here because of the words exciting and the words boring. All right. By phrasing it that way, we're essentially making the people answering this question lean towards the action movies. All right. By making assumptions about this thing. All right. And so the follow-up questions here is, how can we change this question so that it's not biased at all? All right. And so what we would do is maybe we would remove the words exciting and boring, because that's the thing that's making this question biased. See, if I read the question without those words, it would say, do you prefer action movies or documentaries? And see, now it's not biased because we're not making assumptions about action movies being exciting. And we're not making assumptions about documentaries being boring, okay? We could also rephrase the question completely, because maybe just the fact that we're using something like action movies versus documentaries, maybe we want to make it more broad and just say, what is your favorite movie genre? And if you don't know what a genre it is, it's like a topic or a category of movie. So genres would be like action movies, documentaries, comedies, all right, that kind of thing. So maybe we change the question completely, all right? And so there's lots of ways to remove bias from questions, but we have to be careful about that. And sometimes not the question itself. If we look at this particular example, it says you want to know what % of teens watch football on TV. So you survey every third teenager at a high school football game. And the question now is this survey biased? Is there bias in some way? And the answer is yes, not because of our survey method and not because of the question we're asking, but because of the situation in which we're asking it. Okay? We're asking teenagers who are leaving a football game if they watch football on TV. So aren't we more likely to get teenagers that say, yes, I watch football on TV if they're leaving an actual football game? Okay? We'd be better off sampling every third person leaving like the mall or something like that. Okay? So yes, there's bias because we're surveying teenagers who already watch football in some capacity. And so we ask ourselves, would they be more likely to watch football on TV if they already watch football in person? And the answer is probably yes. So again, to change that, to fix that, we might go survey at a different location. Instead of surveying every third person that leaves the football game, we go to some neutral location, all right? So it's the fact of where they're taking these samples from that makes that one biased. And then this one, you want to know how many of your classmates have a cell phone. You send every classmate an email asking, do you own a cell phone? How might this method affect the results? Well, because you're not requiring them to do it, not everybody's going to fill this out. So not everyone is going to respond. And if someone is embarrassed by the fact that they don't have a cell phone, this could create bias here as well, because they might not want to respond because they're embarrassed by the fact that they don't have a cell phone. Not that I think that's embarrassing, because cell phones are the worst, and we all know that. Okay, so there could be some bias here as well. But again, the whole point of this is making sure that when we're taking samples and surveys and things like that, that our results are going to be free from bias, and they're going to be able to give us data that can be used effectively and efficiently. If we have bias in our questions, if we're not surveying and getting our samples collected correctly, then our data is going to be tainted, all right? Which means it's going to be no good. All right. So that's kind of what this is all about. This is a prelude to the things you're going to do in things like statistics. And really, we got to make sure that that data is valid. All right. And that's what this is all about. Okay.